Okay, so today we are, this session we're gonna talk about the first chapter, okay? And after the first chapter, we will have a quiz one, which is due on the midnight of February the 14th, okay? So lecture one or chapter one is about economic questions and data. This is an introductory chapter. Um, we'll talk about economic questions we examine. We'll also talk about causal effects and idealized experiments. And lastly, I will also introduce several different types of data. Okay. So what kind of economic questions we examine? So usually we ask a question like, does A affect B? Okay. A is usually a policy. It could be minimum wage. It could be federal funding for vaccines, or something you can control. Okay. B is usually an outcome or something you want to achieve. So for example, unemployment rate can be an outcome. Okay. You want to achieve a low unemployment rate. Okay. So in that case, we have several examples. Question one, does reducing class size improve school grades? Okay, so the policy part is class size, okay? Do we want to reduce class size? Do we want to hire more teachers to improve school grades? Question two, how much do cigarette taxes reduce smoking? So this question is also contains the policy, which is cigarette tax, okay? Cigarette tax can be high, can be low. So we want to know what should be an optimal cigarette tax to reduce smoking, okay? Because we want to tax people who smoke to discourage them from smoking, but we don't want them to lose a ton of money if they really want to smoke. Okay. Question three, is there racial or gender discrimination in the home loans market? Okay, so here it's a little bit different. Um, in here, the policy side is actually not existent. Okay, in here, A is not something we can control. A is race or gender. Okay, but what's the point of understanding status or something we can control on an outcome which we want to achieve? So for example, we want equality in the home loans market. So question three is usually useful in times when we want to determine if there is inequality. Okay, if there is inequality, then we want to understand what causes inequality and how we can change that. So question three is not a typical does policy A affect outcome B, but it's also some type of economic questions that we examine. Okay, and once we know does A affect B, then we can make a forecast about policy A. Okay, so for example, we would say that policy A, like minimum wage, we forecast if that is gonna increase the earnings of people, or we're gonna forecast if that's gonna make employers fire people because the minimum wage has increased. So we can make a forecast after we answer these kind of economic questions. Okay. So here I want to talk about something that we will keep on discussing during this semester, which is causal effect. So what is causal effect? It is important to compare causal effects and correlation, okay? We always say correlation is not causal effect, but what are they? So causality means that a specific action leads to a specific consequence, okay? So we typically means that A causes B, okay? Correlation, however, doesn't mean A causes B. It usually means A and B happens in the same direction or opposite direction. Okay, so we in statistics we mean that correlation means two variables move in the same or opposite direction without any implication for causality. Okay, so for example, ice cream sales and drowning. Okay, so ice cream sales and drowning happens in the same direction because when the weather gets hot, people people will buy more ice cream. And when the weather gets hot, people goes to swim and then drowning happens. Can you say that ice cream sales causes drowning? Um, Definitely not, because if drowning is caused by ice cream sales, then to prevent drowning, we just need to cancel all the ice cream trucks. Okay, but that's not going to help for drowning, right? So drowning and ice cream sales move in the same direction. They are correlated, but there is no causality between them. There is no cause or consequence between these two. Okay. So it is important for us to estimate causal effects because as we go back to the question, does A causes B? We want to know, does policy A really help us to achieve outcome B? So we want to estimate that. And how are we going to estimate it? So here, the idealized situation is that we can run an experiment, okay? We call this randomized control experiment, or RCT. So in this experiment, we have a treatment group and a control group. In the medical field, the control group is sometimes called placebo. Okay, so RCT, if it's done carefully and well designed, it can determine the causal effect. Okay, so here I'm going to introduce you some RCT examples. Okay, so let's start from the medical field. Um, a hot topic today is, how is vaccine efficacy calculated? Okay. How do we know vaccine really protects people from this virus? We don't know, right? Because even in the lab, if we draw people's blood and we find there is antibody in it, we don't know if they are sufficient enough to protect our body from infected by the vaccine. Sorry, by the virus. So here's what they do. In phase 3 trials, the vaccine companies is gonna find some volunteers and randomly assign them into experiment group and control group. Okay, so it is important for us to randomly assign them because some volunteers are very risk taking. Some volunteers are risk averse. They are very protective of themselves. So we don't want one group to have a majority of some type of volunteers and another group to have another type. So it is important for us to randomly assign volunteers into these two groups. Okay, so experiment group got the real vaccine, and it is also important that they don't know if they get the real vaccine because that would change their behavior. Okay, if they know that they get the real vaccine, they're gonna go to subway stations and go to indoor dining and indoor gatherings. And then that would increase the risk of them catching this virus. While if the control group knows that they get the fake vaccine, okay, they're going to be very protected. They will be staying at their homes all the time because they know that they're not protected. So that's not going to help us determine causality. So randomization is important. We have to randomize them, and we have to have a blind setting, which they have no idea which group they are in. Okay, so now after we administer the vaccines, we let these people go home, do whatever they are doing, okay? Because they don't know if they get the vaccine or not. These two groups will not have a significantly different behavior. Okay. So we'll wait for them to get COVID, okay? We're gonna call them every week to ask them if they have any symptoms. If they said, oh, I have some symptoms, I lost my taste, or I had a fever, then the vaccine project people are gonna take them in and administer some tests to determine if they actually get COVID or they just get a flu or a cold, okay? So this is the graph of the Pfizer vaccine, okay? if we look at the blue line and the red line, this is accumulated of amount of people or accumulated incidence of COVID-19 occurrence. That is the accumulated chance of this whole group getting the virus, okay? So we can see that on day 0 to day 7 or to day 10, the blue line, the red line are relatively just at the same point, okay? Here. So here. Here. So we can see that the blue line, the red line are the same because you get the vaccine or the placebo at day 0, but it takes some days for the vaccine to actually work. So from day 0 to day 10, both group have same amount of people getting the virus. Okay. However, after day 10, these two lines start to deviate. Okay. Especially after day 21. Okay. We can see that the red line just goes straight up. Okay. Because these people just get the salt water. Okay. But the blue line, okay, they are protected because we can see that the blue line people, they still have people getting the virus, but the amount of people getting the virus is way less than the red line. Okay, so here, if we select a cutoff point, okay, because at some point they have to calculate the efficacy. So if they select a cutoff point, let's say at day 77, and they find out that, oh, there are 5 people in the vaccine group who catch the virus, but there are 100 people in the placebo group that catch the virus. What does that mean? That means that 95% efficacy. Why? Because if both group, let's imagine both group have got the fake virus, then ideally or theoretically both groups should have 100 people who catch the virus. However, now the vaccine group only have 5. So that means there are 95 people who have already encountered the virus at some point, maybe through a family member or something. But the vaccine or the antibodies in their body protected them from catching it. Okay. So at the end, only 5 people tested positive. Okay. So then in that case, 100 minus 5 divide by 100 gets us the 95% efficacy rate. Okay. So this is a very typical randomized control trial. Okay. And it's very commonly used in the medical field. How are we gonna do it in economic field? Okay. So I'm gonna introduce a more kind of like more live related example, which is in tech companies. How do they decide how to roll out their websites? Okay. So in tech companies, they also do randomized control trials. Okay. So what they do is they need to decide if they should put a picture here. Okay. This is their A, okay, their policy or something they can control. What's their consequence or what's their outcome? The outcome is how much of people come to their website that actually checks out or actually buy something from this website. Okay. So this is what they do. They randomly select or they randomly divide their customers or whoever click on this website. Okay. So whoever click on these websites, they will be randomly assigned into a control group and a variation group. Okay, you can call it variation group or experiment group. The control group is gonna see this pre-order picture, and the variation group is not gonna see it. What they're gonna do is they're gonna calculate the checkout rate in the customers or anyone who have been onto this site and see if there is a difference between them. So what they find is that there is 43% increase in checkout in the variation group. Now, I don't really understand why people tend to check out more if there isn't a picture, right? Because in the control, it seems like you can obviously see that there is a $20 off, but in the variation you don't see it. So I don't really understand what's going on, but this is what the data tells us. It's a randomized control trial, so it it determines causality. Okay, um, it's also very important that there are enough customers. Okay, if you only have 2 or 3 customers and you randomly assign them into 2 groups, that's not gonna tell. Okay, at least you have thousands or hundreds of customers and randomly assign them into these 2 groups that you can determine the causality. Okay, so these are how the online companies um, evolve. Okay, they constantly do these kind of extra experiments to decide what kind of versions can they make more money. Okay, um, I'm gonna show you one more example. Okay, this is a socks website. Okay, we have a control version that all the socks are displayed in different sizes. Okay, some socks are kind of like highlighted, but in the variation group, all the socks are displayed um, in like a table that is very regular. Okay, so control seems more fun, and there is also a picture up here, but the variation seems like more boring but more product oriented. Okay, so at this point I can't tell. I just feel like probably the variation version is more comfortable to look at. Okay, because you can directly focus your attention on socks, or maybe because you can see more socks on one page, so that increases the average revenue per visitor. Okay, so if you have enough visitor into this website and you randomly assign them into 2 groups, then you can calculate the average revenue per visitor, and you find out that, okay, the variation group have higher revenue. So the variation version will be the last version that we posted on this website. Okay. All right. So these are some examples of randomized control trial. Um, we will have more example later in the class. Okay. Lastly, I'm gonna introduce some data types. So first, we say that there is experimental data and observational data. This is very easy to understand. Experimental data comes from experiments, okay? Because it comes from experiments, and if it's a good experiment, then it's very easy to use the experimental data to determine or to estimate causal effects. We also have observational data, okay? Because in the real world, we can't do experiment on everything. Okay, we cannot test. Well, there are a lot of things we cannot test. Okay, we cannot test. Let's say, punishing people for something, and it could have ethnical issues or something. Um, so so for example, in the big economy, for example, monetary policy, you cannot randomly assign countries into 2 groups, and one group have one type of monetary policy and another group have another kind of monetary policy. That doesn't work. So in the real world, a lot of the cases experiments cannot be done. So people have observational data. It's always collected through surveys or other collection methods. So observational data are valuable, but sometimes challenging to estimate causal effects. Okay. Another type of categories are cross-sectional data, time series data, and panel data. So you can expect some multiple choice questions here. Okay, so cross-sectional data, it's data on different entities, okay? These entities can be workers, countries, firms, or consumers, or governmental units like countries. But they are only observed in one single period of time. Okay. So multiple entities, one time period, they're called cross-sectional data. So this picture is an example. This is 2018 GDP of a lot of countries. So this is only one period of time, right? It's only 2018. But we have multiple entities. We have so many different countries. So we call this a cross-sectional data. Time series data. Okay. So what's time series data? Time series data are data for one single entity, but collected at multiple time periods. Okay, so for example, this is a fun stock that has a very dramatic stories this year. So if some of you know that, you can follow it, but I'm not here to encourage you to take risk in stock market. Okay. Um, the entity is the price of this stock. Okay. We only have one stock here, so we only have one entity. But we have followed the price of this stock for multiple time periods. You can see that we follow them for 1 month. So we have its price for every day. Okay, this graph is drawn by I think it's average value. Okay, I probably average or probably, I don't know. So I observe the average price of every day for the past month, and then I draw this line. So this is called time series data. Okay, we have only one stock and we have multiple time periods. Okay. Um, so then next you can imagine what it is. It's called panel data. Okay, so panel data is data for multiple entities, and each entity is observed in multiple time periods. Okay, so for example, you can have GDP for all US states from 2000 to 2020. Okay, so multiple entities, 50 states, and multiple time periods, that is 20 years. Okay. Another example is prices of these fund stocks for multiple time periods. Okay, so here you can see in this picture that we have 3 entities and we observe them for multiple time periods. Okay, so this is an example of panel data. And you should also know that panel data is also called longitudinal data. Okay, so that's it for this. That's it for this chapter. It's very introductory. We don't have much things challenging here. And you're gonna finish quiz 1. Okay, you're gonna finish quiz 1 by the midnight of February 14. Okay, so I will see you. Let me think. So next week I will post another Thursday session, but next week we will not have a Tuesday Zoom meeting. Okay. All right. I will see you in next Thursday session.